Welcome to this explainer where we are going to tackle, literally, the absolute ultimate boundary. We're always told that the universe is everything, right? All of space, all of time, all of matter, the whole shebang. But if the universe is expanding, you have to ask yourself, what exactly is it expanding into? It's the kind of question that keeps cosmologists awake at night. And today, we're going to explore the mind-bending theories that push way beyond the edges of our known reality. We're going to dive into higher dimensions, multiverse oceans, and even the end of time itself. Okay, so let's jump right into this by first looking at what we actually know about the Big Bang and exactly why it leaves us constantly searching for an outside. When we imagine an explosion, we usually picture it expanding into an existing empty room, right? Like a firecracker going off in a massive warehouse. But standard cosmology tells us that space itself is what's expanding. It's kind of like the rubber of a balloon stretching out as you blow air into it. To really wrap our heads around how that can be, we need to correct a pretty major misconception about how this whole thing started. So, as theoretical physicist Alan Guth points out, the early Big Bang theory didn't actually explain the bang itself. I know, right? It didn't tell us what banged, why it banged, or what was going on before it banged. It really just described the aftermath of a massive repulsive gravitational push. The Big Bang is essentially just the story of the cooling, expanding soup of particles that was left behind. So, to find the true outside, we have to start our journey at the very edge of the known universe by focusing on two major cosmological clues: cosmic inflation and the cosmic microwave background. Section 1. Beyond the Big Bang, the edge of the known. Okay, so Alan Guth famously proposed the theory of cosmic inflation. He realized that inflation actually explains the bang of the bang. He theorized that a really, really tiny patch of incredibly high-energy material triggered a ridiculously rapid exponential expansion. And the fuel for this crazy expansion? Negative gravitational energy. This means gravity actually acted repulsively, literally pushing space apart faster than the speed of light. Just imagine taking a region the size of a tiny glass marble and violently stretching it to cosmic proportions in a fraction of a second. That is the true bang. Now think about the number 13.82 billion. That's the age of our universe in years. The light released just after that crazy Big Bang expansion cooled down has been traveling toward us for exactly that long. And that creates an observable boundary, a horizon. We physically cannot see past the distance that light has traveled. So the great unknown is sitting just beyond that edge. But what if we zoom out past that horizon? What if inflation eventually stops in our local patch, but just keeps going everywhere else? Well, that leads us to step completely outside of our own space. Section 2. Bubbles in the multiverse. Stepping outside space. This brings us to a totally mind-boggling concept called eternal inflation. According to this theory, the repulsive gravitational expansion that created our universe is just one nucleated bubble, meaning just one tiny bubble forming and separating, inside a constantly expanding, super high-energy cosmic ocean. While inflation stopped in our local patch, which allowed matter to cool and all our beautiful galaxies to form, the space outside our bubble just continues to inflate at an accelerated rate, violently spawning infinite other pocket universes. It's a wildly massive scale to try and even imagine. Think of it kind of like a boiling pot of water. A recent preprint on the bubble theory suggests our entire 3D universe is just a single expanding bubble that formed in a quantum, fluid-like primordial ocean. In this framework, the boundaries of our universe aren't just empty, dead edges. They might actually reflect and encode information, or even interact with an external dark energy fluid. Imagine that. Our entire reality is basically just the fizz in a cosmic soda. But what if we aren't just isolated bubbles floating in a massive 3D space? What if we need to look in a completely different direction? What if we're floating in higher dimensions? Section 3. Brains and higher dimensions. Stepping outside dimensions. Enter brain cosmology, which actually comes to us from string theory. The core idea here is that our entire three-dimensional reality is restricted to a brain, which is just short for membrane. So imagine a perfectly flat sheet of paper. Now imagine that sheet of paper is floating inside a much larger, higher dimensional hyperspace called the bulk. In this scenario, we can't point to the outside of our universe because the outside exists in a fourth, fifth, or even higher spatial dimension, dimensions that we physically cannot perceive. Seriously, have you ever stopped to wonder why a cheap little refrigerator magnet can pick up a paperclip, entirely defeating the gravitational pull of the entire Earth? It's a huge physics mystery that has puzzled scientists for decades. gravity is shockingly weak compared to electromagnetism and the nuclear forces. But why? Well, the answer might be that gravity leaks. In brain cosmology, light and matter are tightly stuck to our 3D brain. They can't leave. But gravity is special. It's not completely constrained by our dimensions. Instead, its attractive power actually radiates and leaks out into the extra dimensions of the bulk. So the reason gravity feels so weak to us is simply because we are only experiencing a tiny fraction of its true force. The rest of it is spilling out outside the universe. Okay, so we've stepped outside of space, and we've stepped outside of our physical dimensions. But Nobel laureate physicist Roger Penrose asks us to take an even wilder leap, to step outside of time itself.
Section 4. Universes before and after. Stepping outside time.
Penrose points out a truly fascinating fact. In the extremely distant future, long after all the stars die and all the black holes evaporate, the only thing left in the universe will be massless photons, particles of light. Now, because mass is fundamentally required to build a clock and actually experience time, a universe entirely devoid of mass is a universe that literally forgets how to keep time. As Penrose beautifully puts it, eternity is no big deal to a photon. They don't experience time at all. So the crucial point of what Penrose calls conformal cyclic cosmology is this. When an exponentially expanding, infinitely cold, completely empty universe loses all its mass, it forgets how to measure time, and critically, it forgets how to measure distance. Mathematically, a universe that doesn't know how big it is becomes entirely indistinguishable from the tiny clockless singularity, an infinitely dense zero-volume point of a brand new Big Bang. The outside of our universe in this model is simply the universe that existed before ours and the one that's going to exist after. When we pull all these theories together, a really incredible complete picture starts to build. Whether we look at bubble theory in a multiverse ocean, brain cosmology floating in the dimensional bulk, or cyclic cosmology looping through eons of time, these cosmological clues all point to one undeniable possibility. Our universe is just a single component of a much grander, unseen architecture. Section 5. An interconnected living universe. The unitive universe. Now, you might be asking, so what? How does this immense, mind-bending cosmology affect our actual lives here on Earth? Well, according to recent discussions by the Club of Rome, discovering that the universe extends beyond our perceived boundaries forces a massive paradigm shift. We have to completely abandon the old 19th century materialistic view of a universe made of isolated, meaningless mechanical cogs. Instead, we have to embrace an emergent unitive view, where reality is fundamentally relational and matter is basically just organized information within a deeply interconnected whole. We actually see proof of this relational reality down in quantum mechanics. Quantum entanglement, which won the Nobel Prize in Physics back in 2022, by the way, shows that particles remain intimately linked. They instantly communicate, entirely ignoring the speed limit of space. Our universe is built on these deep, instant relationships, not just on isolated chunks of matter randomly colliding in the dark. And we see these exact same relational patterns echoing at every single scale of existence. I'm talking about the exact same fractal branching in river networks, human blood vessels, and the cosmic web of galaxies. We see the exact same mathematical power laws governing earthquakes, the growth of human cities, and the clustering of stars. From the subatomic to the cosmic, organized information is taking physical form in repeating, interconnected ways. This means that whether we are tangled across multiverse bubbles, floating on higher dimensional brains, or echoing through cycles of time, the universe is not a dead machine. It's a deeply interconnected, living web where every single part is related to the outside. The boundary between us and the rest of the cosmos is entirely artificial. Which leads us to the end of our journey today. I want to leave you with this final, provocative thought to ponder. If we are truly interwoven into this infinite relational multiverse, if the exact same patterns that beat in our hearts govern the birth of pocket universes, what does that mean for our future as a species? How does understanding our deep, fundamental connection to the outside change the way we treat the inside of our own planetary home? Thank you so much for exploring the edge of the universe with me. Keep wondering and keep looking up.